In the last classes, I have explained to you what is an array and what are the different types of an array. What is an array and what are the different types of an array. In this class, I am going to explain how to declare a array variable and initialize how to initialize the array variable, how to declare an array variable and how to initialize the array variable, that is storing the values into the variable and retrieving the values, storing the values and retrieving the values from the array variable. So there are different types of arrays: single dimensional array and multi-dimensional array, that is double dimensional array. So before entering into the topic, I would like to give a brief about the previous classes, previous video sessions, for better understanding, that is what is an array, and how it differs from a normal variable, So in the C language they have provided three different types of data types. They are basic data types, derived data types, user defined data types. And in the second chapter we have seen the basic data types such as int, float, and character. Int, float and character. Here the arrays comes under derived data types. The arrays comes under derived data types. The derived data types are extracted from the basic data types. So the derived data types are having the features by combining extra feature to the basic data types. Basic data type plus additional feature, we can say the derived data types. In a simple manner, a basic data type variable, if you take integer, it stores only a single value. The range of integer data type, that is 32,767 to 30 plus 32,767 minus 32,768 to plus 32,767. So in that we can store a single character. Or else if you take this character variable, a character variable stores only a single character. If you want to operate strings, a string is nothing but collection of characters, that is our names, Telangana, Hyderabad, and the names like Raju, Ravi. So these are all called as strings because a string is a collection of characters. So here a character variable can store only a single character. A character variable can store only a single character. But how to store the names? How to store the names? Okay, so in the character variable we can store only a single character, that is of 1 byte, that is of 1 byte. But here I want to store my name, I want to store my name. How? Then in that situation we need we need a character array, we need a character array. With the help of this derived data type, the character array, we can create multiple locations of same data type, multiple locations of same data type, and referred with a single name, referred with a common name or single name. Like that we can store the strings and we can manipulate the strings, we can make operations on string with the help of this character arrays. A character is a data type, char is a data type, it can store only a single character. In order to store the names like strings, like names, or we need a array and the character array. Okay, the character. And if you want to store 10 subjects marks of a students, in that situation we need character. We can create 10 variables of same type integer, but the memory for each and every variable is created at a different places, at a different locations in the physical memory RAM. So accessing that individual locations, each location, for inserting values and retrieving the values from the locations, from the memory location, it is a time taking process to the processor. So that is the problem. To overcome it, the arrays were introduced. And an array is a, it is nothing but to store a list of values. An array is a common memory locations, or it is a sequential memory locations, referred with a common name. An array is a collection of similar data type. An array is a collection of similar data type variables that are stored in a continuous memory locations, continuous memory location. So the arrays are created, the array we can create to the basic data types such as int, char, double, float. If you want to store multiple locations, if you want to create more variables of same type, instead of creating individual locations, individual variables, we can create by using a single variable like an array, single variable like an array. It's a collection of values, collection of memory locations in a sequential order to store the values of same data type. Here to store the values of same data types. See this one, already we have seen this diagram in the previous video also. You have seen this diagram in the previous video also. It's a continuous memory locations. It is showing the array is created in a continuous memory locations, in a continuous memory locations. Here we got one point. After understanding the previous video and this discussion, an array is a variable, an array is a variable, it is a referred with a common name, and it is a collection of sequential memory locations of same data type, of same data type. So here the array is created in the memory like this. How to? There are different types of arrays, there are different types of arrays: one dimensional, two dimensional, and multi-dimensional arrays. One dimensional, two dimensional, and multi-dimensional arrays are. So how to create an array? How to create an array? So declaration of one dimensional array, declaration of one dimensional array. So array must be declared before they are used. Array must be declared before they are used, so that the compiler can allocate sufficient amount of space for them in memory. Declaration of one dimensional array. Arrays must be declared before they are used. Arrays must be declared before they are used. Before they are used, so that the compiler can allocate sufficient amount of space for them in memory. The general form of array declaration is data type, variable name and size. Data type, variable name and size. This is an example: int even of 5. Int even of 5. So whenever you write a statement, whenever the compiler sees a statement like the array declaration, that is data type, variable name and size. Data type, variable name and size. Int even of 5. Int even of 5. Here it means this is the data type. This is the data type. This is the data. See this example. So here the main function that is int even of 5. Number of memory locations required. Number of memory locations required. So for example, I will show you one more example here for better understanding. See here, main is a function. Here I am declaring int a comma b comma c comma d comma e. C comma d comma e. So these are the 5 variables, integer variables of same type, that is data type is int. So instead of creating individual variables, you can create an array like this. Main int a of 5. Int a of 5. So this is equivalent to this one. All these 5 variables, 5 locations is equivalent to this single statement int a of 5. Int a of 5. So here, for the location a is allocated, the array is created this. This is 0, this is 1, 2, 3 and 4. So how many locations are there? 5 locations. 1, 2, 3, 4, 5. How many locations are there in the 1, 2, 3, 4, 5 memory locations? 5 here, 5 memory locations. 5 memory locations. 5 memory locations. The memory locations are 5. The memory locations that are created are 5 here. So these are called as index numbers. The location number starts with, the first location number starts with 0. So how to access this memory locations? How to access this memory location? Using its index numbers. Index numbers. These are called as index numbers. Index numbers. Index numbers. These are called as index numbers. Using its index numbers, we can access that location. These are all index numbers. Using array index numbers, using index numbers, we can access the array. We can insert, using its index numbers we can access it. Using index numbers only we can access. How? So here a of 0, a of 1, a of 2, a of 3, a of 4. So here a of 0 refers to this location. A of 0 refers to this location. So here a of 0, a of 0 refers to this location, a of 1 refers to this location, a of 2 refers to this location, a of 3 refers to this location, a of 4 refers to this location. Here a of 0 refers to the first location number, first index number. A of 1 refers to the second index number. A of 3 refers to the A of 2 refers to the third location. A of 3 refers to the fourth location, and A of fourth refers to the fifth location. How many locations are there? The total locations the total locations are 5. The total locations are 5 memory locations. 5 memory locations. The total memory locations are 5. The, the total locations are 5. The total locations are 5 memory locations. Using index numbers we can access it. Using index numbers we can insert the values and we can retrieve the values. We can retrieve the values also. Using index numbers only we can insert the values, and using its index number only we can retrieve the value. This is the normal variables a comma b comma c comma d comma e is equivalent to one single array variable. Here the normal variables there are 5 different names a b c d e, and here the array variable, in the array variables there are 5 locations referring with a common name. There are 5 locations referring with a common name. 5 locations referring with a common name. So that is the advantage of array. That is the advantages of arrays. That is the advantages of arrays. These are the 5 integer variables. 5 integer variables. 5 integer variables. This is the array variable. This is the array variable. This is the normal 5 integer variables, and this is the array variable. How to access this array variable? With its index numbers a of 0, a of 1, a of 2, a of 3, a of 4. With its index numbers a of 0, a of 1, a of 2, a of 3, and a of 4. By using its index numbers, we can access. By using its index numbers, we can access the locations. You can access the array locations. Is it clear? This is one example and this is another example. This is one example and this is another example. So next, initialization of one-dimensional array. How to store the values? Here, by using this index numbers, we can store the values. By using this index numbers, we can store the values into an array. By using its index numbers, we can store the values into an array. That is, a of 0 refers to the first location, first index number. A of 1 refers to the second location, second memory location. A of 2 refers to the third memory location. A of 3 refers to the fourth location. A of 4 is the fifth memory location. So if you declare 5 memory locations, means A of 5 means it is a 5 locations. A of 5 means it is a 5 memory locations, but the index number starts with 0, then less than the size. The index number starts with 0, then less than the size. So 0, 1, 2, 3, 4. Then the 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. There are 5 locations. 0, 1, 2, 3 are 5 locations. There are 5 locations, that is 0 to 4. 0, 1, 2, 3, 4. The number of locations are 5. 0, 1, 2, 3, 4. The number of locations are 5. The number of memory locations are 5. Then how to store the values? This is called initialization of one-dimensional arrays. Initialization of one-dimensional array. We can initialize. This is a one-dimensional array. This is a one-dimensional array. This is a one-dimensional array. Here I will write one-dimensional array. One-dimensional array. This is a one-dimensional array. One-dimensional array. The type specifies the type of data that elements hold. Then initialization. Here int, we can say int a. The type specifies the type of data the elements holds in the array. The type specifies the type of data that elements holds in the array, such as int, comma, float or char, and the size indicates the maximum number of elements that we can be stored inside the array. The size indicates the maximum number of elements that can be stored inside the array. For example, int a declare this group containing 5 elements. Declare this group containing 5 elements from 0 to 4. From 0 to 4. Here we can interchange this. Declares the group to be an array containing 5 elements, that is the index number from 0 to 4. Index numbers from 0 to 4. Initialization of one-dimensional arrays. We can initialize the elements of arrays in the same way as the ordinary variables. The general form of initialization of array is type array name size is equals to list of values. Type array name size is equals to list of values. The values in the list are separated by commas. The values in the list are separated by commas. For example, the statement is int value 5 is equals to 10 comma 20 comma 30 comma 40 comma 50. Initialization of one-dimensional array. We can initialize the elements of array in the same way as the ordinary variables. We can initialize the elements of array in the same way as the ordinary variables. The general form of initialization of array is type, that is data type that is data type, and array name size is equals to list of values. The values in the list are separated by commas. For example, the statement is the values in the list are separated by commas. The values in the list are separated by commas. For example, the statement int values of 5 is equals to 10 comma 20 comma 30 comma 40 comma 50. Into value of 5 is equals to 10 comma 20 comma 30 comma 40 comma 50. 10, 20, 30, 40 and 50. The values in the list are separated by commas. For example, the statement into value 5 is equals to 10 comma 20 comma 30 comma 40 comma 50. 10, 20, 30, 40 and 50. This is the initialization of array. This is the initialization of an array. And the size may be omitted. In such a case, the compiler allocates enough space for all initialized elements. For example, the statement, if you are declaring character array, we can give char name is equals to Raju declares the name to be an array of 4 characters initialized with the string Raju ending with the null character. Alternatively, we can assign the string literally direct as false. Directly as follows. Directly as follows. Directly as follows. Initialization of one-dimensional arrays. You can initialize the elements of array in the same way as the ordinary variables. You can initialize the elements of arrays in the same way as the ordinary variables. As the ordinary variables. You can initialize the elements of the array the same way as the ordinary variables. The general form of initialization of array is data type, array name, size and list of values. Here the values in the list are separated by commas. For example, the statement int a of 5 is equals to 10 comma 20 comma 30 comma 40 comma 50. Int a of 5 is equals to 10 comma 20 comma 30 comma 40 comma 50. Int a of 5 is equals to 10 comma 20 comma 30 comma 40 comma 50. So the size may be omitted. In such case, the compiler allocates enough space for all initialized elements. For example, the statement char name is equals to Raju. Char name is equals to Raju. R comma a comma j comma u. Char name Raju slash 0 declares the name to be an array of 4 characters. Declares the name to be an array of 4 characters initialized with the string Raju ending with the null character. Initialized with the string Raju and ending with the null character. Alternatively, we can assign the string literal directly as follows. We can assign the string literal directly as follows. And an array can be explicitly initialized at runtime. An array can be explicitly initialized at runtime. This approach is usually applied for initializing large arrays. For example, considering a following statement. So here we can initialize the arrays by using loops also. The loops are used to initialize the arrays at runtime. For example, I want to read some numbers from the keyboard. I want to read some numbers from the keyboard and I want to store it into arrays. I want to read some numbers from the keyboard and I want to store the numbers into the arrays. I want to read some numbers from the keyboard and I want to store that numbers. I want to store the numbers into the arrays. So at that time we use for loop or while loop. We use for loop or while loop to read the values from the keyboard by using scanf statement and to print the values by using printf statement to print the values by using printf statement and to read the values by using scanf statement. By using the scanf statement, we can print the values. We can read the values and we can print the values. You can print the values and we can read the values. Here, observe here. We can initialize the array. We can initialize the array. Initialization means we can store the values into the array in two ways. Directly we can store the values like this. Directly we can store the values int a of 5 is equals to 10 comma 20 comma 30 comma 40 comma 50, or else we can store the values. You can store the values by using a printf, a scanf and a printf statement. By using loops inside loop we can write a scanf statement. So that is by reading the values from the keyboard. This is the initialization of an array. Initialization is nothing but at the time of creating an array. At the time of creation, initialization means at the time of creating only we are storing the value. At the time of creating an array location, we are storing the value into it. At the time of creation only, we are storing a value into it. At the time of creating the array values, we are storing a value into it. So that is called initialization of array. So after creating that is int a of 5, like this, after creating int a of 5, this, and we can store the values by using a variable, by using a variable that is called at runtime, that is called at runtime. So by using a variables, that is I variable, or that by using an array, by using a while loop, by using a while loop, and by using a variable, by using a count variable or normal variable, by using a while loop or for loop, we can store the values into an array by using its index number. The variable is used I or count to move from one index to another index. So the control has to move from one index to another index. The control has to move from one index to another index. One index to another index. This is at runtime. So here the while loop check the condition I less than or equals to 10. If condition is true, then if statement checks the condition I less than 5. If condition is true, the num is assigned to the 0, else num of I assigned to as num is equal to num plus I. So here in this example, num of I. So in simple term, you can write this example like this also. While I less than or equals to 5, while I less than or equals to 5, scanf percentage d comma a of ampersand a of I, scanf percentage d comma a of I. An array can be initialized at runtime. We can store the values into an array at runtime. At runtime by using a loop and a variable and a normal and a normal and a normal variable and a normal variable and a normal variable. For example, while a less than or equals to 5, and here and here and here and here I minus minus, here I is equals to, I want to mention here, while I is equals to 0 and I plus plus, I is equal to 0 and I plus plus, I less than or equals to 5, when scanf percentage d comma ampersand a of 5, I plus plus, I less than 5 not equals to I less than I less than 5. So this example I will show you by writing in a TC editor. Thank you.